let's explore bar plots in RStudio environment. In the RStudio environment, we have three different bar plots. One of them is simple. We already investigated simple bar plots when we were talking about univariate analysis. We also have stacked bar plot and clustered bar plots. We're going to explore the difference between stacked and clustered bar plots later. For now, let's see what is the difference of simple with these two. We have one function. The function is called bar plot, and with this function, we can generate all the different three types of bar plots. For generating all of them, the function of bar plot gonna take one argument. That argument is a table. What is different between simple and these two type of bar plots is when we investigate univariate analysis, the table gonna take one variable. However, if our table have two different variables, the generated bar plot would be stacked or clustered. Differentiating between these two, RStudio by default, if you use two variables, RStudio by default gonna generate a stacked bar plot, but we can use one argument to transfer it to the clustered one. Let's start our investigations by example. So this is again, a very fast reminder about the simple variable analysis. We're gonna generate a simple bar plot. This is the function. The usage. xlab means you use the argument xlab. Then you're gonna insert the x-axis lab as you want. The argument of ylab would generate the y-axis label, main for the main title, and you can give it different colors. We already talked about that. The example I'm working with is the property data set. You can find the data set in the Canvas environment. And if you are using the interactive package, it's already inside the package. By the way, I'm going to use the table function to generate a table of the suburb variable in the property data set. I'm going to give a name to the generated table. I'm going to call it my table. You can call it different stuff. After that, I'm going to use this argument, my table. I'm telling R, what is my table? He's giving me this frequency table. 5 property in Albert Park, 7 in Carlton, 7 Docklands, 5 Port Melbourne, and 6 in South Bank. Can you remember? I allocated the table to an R object, which was called my table, right? The first argument is one table because bar plot takes a table, right? And this is a table. Then I'm going to give x-axis a name. I'm going to call it suburbs. I'm going to call y-axis, ylab equals to frequency. I'm going to call it frequency. This main title, which is called frequency of properties in different suburbs, comes from here. I wrote main equals to frequency of properties in different suburbs. Then I give it a pink. If you want to, you can give it different numbers. So different colors. So far, it was just reviewing what we already learned about univariate analysis. Okay. But we already investigated simple bar plot, right? Right now, I want to explore the stacked bar plot. The function, as I already said, is the same. The usage is also the same. It's just going to take one argument, which is a table. What is different? The table for generating stacked bar plots includes two different variables. Let's take a look. In this example, I'm generating a table, and one variable is type, the other variable is suburb. right? Since in generating this table, I used two different columns, I can create a stacked bar plot. I'm generating this table and I'm going to allocate this table to an R object, which is called T1. You can allocate, give it another name. You can give it T2 or whatever name you like. Then I'm gonna run the code T1. I'm asking R what was T1. He's telling me it's a table, includes different types here in the rows, flat, house, and unit, and it includes different suburbs in the column. So guys, please remember that over here, we have the name of different rows here, and the name of different columns over here. Let's feed this table, which is called T1 and includes two variables, to the bar plot function. I allocated this table to the bar plot, and a cool bar plot is created. This bar plot includes different suburb names in the x-axis, and different for example, this is one suburb, right? This is one suburb, and this is another suburb. So different suburbs are put at the top of each other. So in Khartoum, this is one of the suburbs. This is one type of the house. This is the another type, and we have two of these, and we have five of the other one, and as a whole, we have seven houses in Khartoum, seven properties in Khartoum. So as you can see, the suburb variable, the observations of the suburb variable are appearing in the x-axis. Going back to the previous slide, you can see the suburb is in the second option. So the second variable gonna go to the x-axis, and the first variable in the plot will appear in the legend. So type, which included flat, house, and unit, is in the legend. So maybe we would like to consider the point that the second variable goes to the x-axis, which is different suburbs, and the type goes to the legend. Let's include different details to this bar plot. I'm gonna say the x-axis is suburbs by saying xlab equals to suburbs. Then I'm gonna say ylab, which means give the name to the y-axis. Let's call it frequency. Don't forget the comma. And I'm gonna call the main title, which is going to appear here, number of property on different suburbs and different types. Actually, I should change it to number of properties. I'm gonna fix this typo later. Sorry for that. And it comes from here, number of properties on different suburbs and different types. There is a problem with this presentation. What is the problem with this presentation? The main problem of this presentation in this figure is, I know there are different types here. For example, this is one type, this is one type, and this white area is another type. And as a whole, I have 6 of them. It is a cool presentation, but I don't know which color represents which type of the house. I know I have 3 different types of the house, and every color represents one type, but I do not know which color is which type, and I don't like this situation. What I'm gonna do is I'm gonna use an extra argument to fix this problem. That piece of extra argument is this simple piece. I was missing legends, right? I just need to add this argument, legend equals to true, and these are the legends. The white is unit, the gray is the house, and this black one is the flat. So by default, the legend is equal to false, which means we don't need to, the default of R is We don't need any legend, but we need the legend. What we are going to do is write this argument and change the default and ask him to give us the legends. Maybe you think those colors are a bit boring. That's fine. We can change the colors. With this argument, col equals to, again, please remember, guys, whenever we are dealing with more than one value, we have to use the combination function. I want to change the colors to red, blue, and green. I don't forget, because they are more than one color, I have to combine them. Otherwise, are going to get confused. And you see it appears, flat is red, house is blue, and the unit is green. I see in Docklands, the majority of the properties are house. However, in these two areas, in Carlton and Port Melbourne, the majority of the properties are unit. And in Albert Park, we have almost the same distribution of flats and units. If you go to this website, you're gonna see a wide range of colors exist in the our environment. So I can use the other colors. Maybe you don't like the colors I picked, you can change them as you want. And let me show you this website. This is the website. It's a pretty cool website. You see, we have a wide range of colors. Gold, I don't know, gold 1 is like this, gold 2 is like this. We have different types of grays, gray 0, gray 1. I really don't know what is the difference between these grays. They look same to me, but these pinks are pretty different. Deep pink 1, deep pink 3, deep pink 4. You see, deep pink 4 is a bit darker. And we have a very, very wide range of colors. You can use whatever you want. Let me get rid of this website and come back to our slides. The final step is you say, I really don't like this presentation. The bars are at the top of each other. I don't like it. What I like is a is a column, it's the clustered bar plot. So you have to include one argument and it will be changed to what you need. The argument is besides equals to true. What is the meaning of besides equal to true? It means put the different columns, different bars next to each other. Don't put them at the top of each other. So again, it's giving me some information. I see, for example, over here in Carlton, the units are this much, and it's almost the same as Port Melbourne. In Docklands, I have too many. What is this? Is it house? Yeah, it is. And it's and in Port Melbourne and Carlton, I have no house. So this is how I deal with changing stacked to a clustered bar plot.